We have come to the fourth and final video of our e-learning. In this video, we will learn about hemoglobin and denaturation of protein. Let's first look at hemoglobin. Hemoglobin is an iron-containing protein that is found in our red blood cell, responsible for the transport of oxygen. It contains 4 subunits, with each subunit containing a polypeptide chain containing a heme group, and 2 of these subunits are called alpha subunit and the other 2 are called beta subunits. In each of these heme group, it contains an iron atom in the +2 oxidation state, which are capable of binding to oxygen molecules. Since there are a total of 4 heme groups, one molecule of hemoglobin protein can actually bind to 4 oxygen molecules at the same time in a concerted action. For more information on hemoglobin, please check out the link that I included below. Now, let's move on to the denaturation of protein and the various ways that it can occur. We know that the quaternary, tertiary, as well as the secondary structure of protein can be destroyed when we use various methods, and when they are being denatured, we cause them to form random coils of polypeptide chain, and this procedure is called denaturation. And this can occur mainly via changes in pH due to addition of acid-base, salt solution or water, heating, mechanical agitation, addition of organic solvent, or heavy metal ions like mercury, silver, or cadmium. Let's first look at pH changes. A change in the pH environment can have a lot of effect on the amino acid residue, as they contain the carboxylic acid group as well as the amino acid groups. So, when we have a change in pH, the ionic bonds, van der Waals forces, or dipole-dipole interaction can change, which will result in the unfolding of the tertiary structure. Some other effects include coagulation and precipitation of the protein. It is important to note that only tertiary or secondary structures are disturbed by addition of acid, base, or salt, because primary structures are usually formed by very strong peptide bonds, and only on prolonged boiling in strong acid or bases, then the peptide linkages will break to give the respective amino acids. The other way that proteins can be denatured is by using strong heating. Strong heating can disrupt the secondary structure, which mainly consists of hydrogen bonding. As there's an increase in the temperature, the molecule will start to vibrate strongly, such that the hydrogen bondings are being destroyed, and the molecules now can interact with each other, which may result in aggregation or coagulation. Okay, let's now move on to see other ways whereby protein can undergo denaturation. Protein can lose their secondary and tertiary structures when we apply strong forces such as beating, whipping, shaking, or kneading them. This is mostly seen in the example of bread making, where we knead the dough and the protein, gluten in flour undergo denaturation. Another example is when we add organic solvents to protein. We know that proteins are folded in such a way that the hydrophobic regions are usually buried in the core of the protein to maximize on the hydrophobic interactions. The hydrophilic part of the protein, on the other hand, is at the exterior of the protein, as this will form strong hydrophilic interactions with water. So when we add organic solvent to the aqueous environment, it will cause the protein to turn inside out, and this will lose cause the protein to lose their tertiary structures. Another way of denaturing protein is by adding heavy metal ions. Heavy metal ions have strong affinity to sulfur atoms inside the protein, and this can cause the protein to lose their disulfide bonds and result in the change of the structure of protein. After looking at the ways that protein can undergo denaturation, let's look at the result and purpose of denaturation. One of the main functions is that we need to digest protein, and by letting protein undergo denaturation, it becomes more digestible. And another effect is that enzymes are usually made inactive when they denature. This is because of the lock and key mechanism, and when the enzyme loses their shape, it does not retain the function anymore. For more information about denaturation of protein, please watch the video that I have included below. We have come to the end of the e-learning videos. Please download the written assignment below, complete them, and submit them to your respective tutors by the deadline stated above. That's all. I hope you have enjoyed the e-learning. Thank you.